All right, thank you so much for today. Sorry about the little hiccup. Right now I'm going to be kind of explaining a couple of the different methods and the method that this specific lab, the advanced chemistry with Vernier pre-lab questions we're dealing with on why that these specific values are recorded as positive. So first of all, I did want to point out that we kind of just jumped right in and I didn't really give you very much time to read about your, excuse me as I zoom out a little bit, but I didn't give you very much time to read over the introduction here. So we had the introduction. So first of all, a voltaic cell is when a redox reaction occurs spontaneously. Yes, I know that's not the best writing here. It is when it's spontaneous. Spontaneously. So that is the number one thing that we really need to make sure. So that means based on that equation that you were given in your, right here, that means that you need to then have Faraday's constant is positive. Your number of moles is going to be positive. So therefore you always need to have then also a positive E cell potential in order to have a spontaneous reaction. So therefore, E cell must always be positive to be spontaneous. There's going to be some times where you have you're given information where it'll be negative, but then you're then indicating that then it is not spontaneous. So as a reminder for this. So I have two ways that I'm going to show you of how that you can actually approach some of these problems in your pre-lab, in these pre-lab questions right here. So I'm going to show you the way that you have read about and also that you watched on the video notes this weekend, over spring break. So here is the first way. So the way number one. So the way to calculate the E cell potential, which you have seen before, is this fancy Nancy little, I'm going to zoom in again a little bit. So we've got a couple different ways that we can approach this. We can approach it by doing that, what I had mentioned before. We have the E cell is equal to the E of the reduction and E minus the E cell potential of the oxidation reaction. This is actually not even given to you on your reference sheet, but this information is that's something that you'd be familiar with. So after you do this practice. So this is the way you saw it in your videos. So I'm going to show you a quick way. So I did actually change some of the information here that they initially had positive, and so how we are actually able to figure out that this one is that this is a positive and why you end up actually having that. So as you think about, as we have which one is going to be the reducer, which one's going to be the oxidizer, if you have your table of cell potentials, you would notice that the cell potential for the copper going to copper ion going to copper solid is going to be positive 0.34, and then the reverse reaction in this case would have been zinc 2 plus 2 electrons, and so the reduction potential would have been negative 0.76. So what you would then know is that you have a more positive, it is more likely than be reduced. So if it is reduced, it is then going to be the more positive one. So in this case, we're going to keep Cu2 plus and Cus as the positive way. So that's going to be the one that's going to reduce. And so then we're going to plug that then in with got the E red. Excuse me. You got your E red and the 0.34 minus, then you got 0.76, negative 0.76, and then that's where you then get 1.10 volts. So that's where you can then get subtracting a negative, you end up with a positive. So then there is this way too. So I have this kind of mapped out on the next one a little bit easier. So again, we've got the more positive, going to be more likely to reduce. So you just need to figure out which one's going to go where. So in this case, here is the next one. I wrote it out ahead of time. So the next one is the copper 2, and we've got copper 2 and copper solid, and lead 2, copper 2 plus and lead 2 plus, and so then there is our, if looking up on the table, you end up with these two potentials. So which one's the more positive one? The 0.34 is the more positive one. So in this case, you'd end up with 0.34 minus 0.13, and then we end up with a 0.74. So that's the way that you'd pretty much kind of looked at it in your in the videos that you watch this over spring break, and you've also, it would be the same kind of things that you did in your book. So you end up kind of having something like this. So you end up having here, this one is going to stay reduced because it is more positive. It has the reduction potential is higher. But then here we have, here's the reduction. It is a negative 0.13. And so we end up in this case, the 0.13 is then, this is going to be then your oxidized reaction. I'm keeping that negative, so then we plugging that in, we have 0.34 minus negative 0.13, and you end up with 0.47. So that's really how you would work it. Here is the rest of the answers and kind of showing you. In this case, if I was to put this whole reaction, we were only doing, especially for the silver one, I've asked you only for the silver. So the silver is the, this is just the half reaction. If I was going to do the full reaction, I would then multiply this in order to balance it out. So then you end up with something that looks like this, and showing you that I'm keeping the exact numbers that are given in the reduction potential. Then we can use this information. So that is the way that you learned about it in the book, and you also learned about it in your in the video notes. Here is way number 2. So we've got now way number 2, excuse me, on here. So we've got way number 2. This is the way that the Advanced Chemistry with Vernier lab actually presented it. So you've got this way, but you've also got another way. So the way that we talked about it is that. So then what they decided to do is, so whenever you do things that they did, for example, the way that it actually ends up working out is your E cell, if you end up flipping the sign because you wanted to make it so you are showing that there is a change in sign, you end up having to add them together instead of subtracting. So choose whichever way that you feel more comfortable with, but know that find one way, don't switch back and forth. Otherwise it's going to get really confusing. You're going to end up with this one, you're like, okay, those two together. But if you show either way of how you got it, there's the, if you flip the sign, you got your E cell. This one tends to be, in my opinion, a little bit more tricky, because here you just look, you look at your cell potentials, you figure out which one is going to be more positive. That one's then going to be more, if that one's more positive, you're going to end up being more likely to reduce, so the other one will then oxidize. So this one, so for example, if you flip the sign, so like they did here, they flipped the sign of that zinc because they put it in a oxidation reaction where it was a loss of electrons, and so then they flipped their sign to be 0.76, and so then in that case you ended up with having to add those together. So that's like your kind of quick method on there. So one way to also, like I had mentioned before, you can go around this one. I like I said, I think tends to be a little bit more thought process, which the video has the Vernier people did on their pre-lab, so that's why I was getting kind of confused, because it took me a minute to get there. So these would be the cell potentials that you would look up for the copper 2 going to your copper 2 plus to your copper solid to your lead 2 plus to your, so then in this case you then have to think to yourself, all right, so again, similar to the other one, but there's one other step that you would then do. So which one is more negative? That's one way to look at it. Or you could say which one is more positive. So if you say which one is more negative, then that one is going to be less likely to reduce, or you could say which one is positive is more likely to reduce. In that case, then you would then, because you're trying to change the thing from to get the most positive number, because remember we need to get a positive E cell. So this one is going to be more negative, so then we would flip that one to be then a positive 0.13, and then you combine the whole reaction then, and you have your whole reaction crossing out your 2 electrons, and in this case you then end up with 0.34 plus 0.13, and you end up with 0.47 volts. So, and then in that case, this is positive, and this case, this is also showing you that this is spontaneous. So you'd be in good shape. But let's say you accidentally, let's say you're like, okay, I thought I got a little confused and which one is going to be more negative, and for some reason you thought that having which ones you needed to make it more negative. So there is a way that you can then kind of like double check your work, and then in this case you could then, let's say you have your 0.34 and 0.13, same idea, and then you're like, oh, I'm gonna flip the 0.34, and so then this would be a way you wouldn't want to do it, because then unless you were asked what was going on with your reaction, you do the whole thing. If you combine everything, you know that you've got your 2 electrons, and you end up with a reaction like this. You could be asked like a question like this, where is this reaction right here, is this going to be spontaneous? If you're only given the cell potentials of your Cu2 plus and the Pb, so one of those, in that case you would have to then flip. You would be doing this correctly, but I did not give you this equation. Right now we're still focusing on the pre-lab. So then in this case you'd plug that in. So then you'd end up with your E cell, in this case would be negative 0.34 plus negative 0.13. And so then you end up with a negative 0.47 volts. So then that is then not spontaneous. So that is another way, again, you can do it. So this is similar to how if you flip that sign, you can then use this equation of E cell of the E red plus E ox. So then notice here I did flip the sign. I didn't. So both ways I say probably are a little equal in amount of writing that you actually need to do, but this one tends to be, I think, maybe a little bit more of having to flip things around. But again, whatever works for you, use that. Excuse me, it's a little shaky. So here I'm showing you that we then had essentially, this is similar to how the book had then, how this example had been given. So as you go down, you'll notice that, so then here, notice here here it is as a negative 0.13, because in this case I flipped the sign, because magnesium was going to be way more into being in this case going to be the oxidized or the reducing agent, and so then it's flipped, and so then you end up having to put those all together. So those are very similar. They're the same identical answers, got to the same way. So those are 2 ways that you can approach it, hopefully answering some of the questions. Please make sure that you have your lab all completed before you come to class on Wednesday. And if you have any questions, please stop by tomorrow during 3rd, 4th, or lunchtime tomorrow. So which is going to be April 3rd. All right. Thanks again. You're all so awesome. Bye.